Okay, this is going to be a learning experience for some students at Essex. And what I'm going to claim to here is that you're going to be given what's known as a lecture material. Right? We try to keep the lectures incredibly short. However, sometimes we can't do that. I realize sometimes something's really going to draw on for a long time that people lose interest very quickly. You should be aware that in most college environments, though, lectures can drag on for 3 or more hours. And that is students are sitting quietly taking notes while someone speaks for 3 or 4 hours straight. That's tough. All right. Now at Essex, we have 1 hour, 20-minute periods. And typically what we try to do in those 1 hour, 20-minute periods is talk about what needs to be learned. All right. But typically we try to do that, especially when we're in the classroom environment, by being more interactive. All right. But again, you got to start to prepare yourself for making that jump in going into a lecture environment. And what's the problem with lecture environments? You may not enjoy it. I mean, so I've just said that if it's more than 5 minutes long, I'm not going to listen. Well, let's try. All right. So here we are in section 3, the first section we're going to cover. What does it say? It's going to be the based on linear equations. All right. Something you've done in prior courses, whether it was at an Essex County College or another school, really doesn't much matter. You've seen them before. We're still going through that. You're going to notice that a lot of things we do in Math 100 are repetition of what you've done before. It's an absolute repetition. All right. That's something I want to warn you against. That, as you move forward, your education there's less and less repetition. There's more moving forward, something new each day. But this is going to be some of a repetition. All right. Repetition on what? Linear equations. We'll get to that in a moment. All right. At the completion of this section of the notes, students should have done the following. Do the web assignment. But some people do this backwards and say, I'm going to do web assign and not listen to a word you're going to say or a word you're going to do. This is not your goal in education. Your goal in education is try to pay attention, learn the material, and then do the assignment. All right. But now you're going to be doing an assignment after we clear everything out. What I mean, everything in section 3, we're going to complete. All right. You should also try to make some entry in the weekly discussion group. All right. Say something. All right. Say something. All right. So what are we going to do over here? I want to give you the structure of the notes, how they're going to look. We're going to give you a simple review. In the notes, though, we have embedded videos. They may or may not be helpful. If you click on this thing over here, a web browser will open up and you'll be able to watch a video related to this section. It's basically a very short lecture pertaining to what's left. You're going to see these embedded throughout the notes. All right. We'll go through this at the whiteboard later, but we'll go through this. There'll be examples embedded, yada, yada, yada. Then we'll talk about this at the whiteboard. Then we'll give you an example at the whiteboard. Everything is typed up for you, but I'm still going to be working at the whiteboard. All right. I'll still do that. There's videos attached to this. You should see that throughout the notes. All right. We'll talk about everything that's in these notes as a lecture. It'll be a short lecture, though. Eventually, we're going to get to examples. We'll work through the examples at the whiteboard. I'll work through each of the examples at the whiteboard. If you notice, next to these examples, there's little videos. You can also do that. You may need to do that. And the reason for that, sometimes this goes way too fast for students. They can't follow. They can't copy. They have a tough time following. By the way, that's going to travel with you the rest of your lives. You're going to have a tough time following a lecture. That's why some students actually bring a recorder to a lecture. So when they go home, they can re-listen to the lecture. The advantage here is these lectures are being recorded and I will post them later in the week. They'll be posted. You'll see that later in the week. And we'll go through that when we get there. But again, I'll be working through these examples. And of course, people say, oh, gee, you do a lot of work. When am I going to get a chance to work? You will. So what you're going to do, after you see me go through that, you say to yourself, I want to try. And we want to give you the opportunity to try. So what do? We give you more examples for you to try. That's what's called homework. That's something you do outside the lecture period. You go home and you review what we presented to you, and you make some attempt to do homework on a piece of paper. What do we give you? A problem and an answer. I will also publish at the end of the week, me working at the whiteboard, doing these particular problems for those students that want to watch that. You determine what you need to do though, to learn the material. All right. So I'm going to go to the whiteboard now. I'm going to stop this share and I'm going to go to the whiteboard and I'm going to talk through it. And it's going to be a lecture. If for whatever reason, all the study and all the work you're putting in, you need additional help, you come by during office hours and I will be more than happy to help you with the material. There's also tutors available at Essex and they'll be more than happy to help you with the material. I'm going to share a whiteboard with you. Give me a second to do so. I'm going to try to share a whiteboard with you. Okay, so this what lectures are typically going to look like. It's going to be, me at a whiteboard, basically reading the notes to you. All right. So what do I see over here? And I'll go through it with you. All right. So, and certainly I'll be writing on these notes as well. And I'd also recommend it. You may want to print these notes out and also write on it, but you should be following along with the notes. All right. So what I'm going to do over here is going to just kind of read it to you. Not that I read all the notes to you, but I want to start off with maybe some reading to you. Just a simple review. I'm going to say an equation, you see that right here, expresses the equality between two mathematical expressions. So they give me an example. And they say the left side, this is the left side. Then there's an equal sign and there's a right side. So it's a left and right side of the equal sign. So left side and the right side of an equal sign. So what is this doing? It's an equation that says that these things are equal. Well, I'll be honest with you, looking at these things, they don't look equal to me. Like 2x plus 3 doesn't look the same as x minus 1. So I'm going to say in appearance, they don't appear to be equal. However, there's a condition that will make it equal, right? There's a condition. So we're going to say that condition is what's known as the solution to the equation. And the solution to the equation can be the condition that makes this true. So what I want to claim over here is x equals minus 4 is a solution to this equation here. The way we're going to verify that is we're going to plug it in. I'm going to write that down for you. So if I'm going to verify this, I'm going to verify that 2 times x plus 3 is equal to x minus 1. And what did I say? I said x equals minus 4. So I'm going to plug it in. So someone said, what did you just do? I looked at this equation, I parenthesized the variable, and I plugged it in. I don't know if this is true. Let's see if it is. What's 2 times minus 4? Minus 8 plus 3 minus 4 minus 1. What's minus 8 plus 3? Minus 5. And what's minus 4 minus 1? Minus 5. I hope you can agree that minus 5 does equal minus 5. The condition that made that true is x equals minus 4. That's the solution to the equation. Again, it's important. The solution makes our equation true. All right. So let's talk about the next thing up is to solve an equation. All right. So we'll talk about this now. We're talking about solve an equation. So to solve an equation means to find a solution. We want to find a solution of the equation. What does that mean? Some condition that makes the equation a true statement, just like we did before. Had they come up with that? I don't know. So for example, let's take a look at that over here. And again, it's a familiar example. We were given this example before. Do you remember? This is an equation. There's a mathematical expression on the left, and there's a mathematical expression on the right. The condition that made this a true statement was x equal minus 4. How do we know that? We checked it. Let's go to the next page. And these are going to be the central rules and procedures. All right, let's talk about that. Essential rules and procedures for solving what's known as a linear equation. I wouldn't worry so much about a linear equation. We're going to give you linear equations. And this is a nice foundation to solving equations in general. The number one step, and I can't get this across enough, you need to simplify both sides of the equation. For some students, that may mean clearing the equation of fractions, because fractions for some students are very difficult, and decimals. It may. I'm not saying it has to, but I think you know what simplification means. Adding like terms, removing grouping symbols, yada, yada, yada. Number two, get the variable term on one side by adding or subtracting the same variable expression to both sides of the equation. And we'll go through examples. Number three, get the constant term on the other side. Now, so what do you mean the other side? Well, if the variable's on the left, the constant will be on the right. If the variable's on the right, we want the constant on the left, the other side. It's the opposing side. By subtracting or adding a constant from both sides of the equation. This is what's known as equal and fair treatment. So we can add the same thing to both sides of an equation. We can subtract the same thing from both sides of the equation, and it'll still remain to be equal. Step number 4, and we'll go through examples. Divide both sides of the equation by the variable term's numerical coefficient. The 5th step, which I always say is optional for many students, is to check your solution. Let's take a look at an example. I'm going to pull this example on the side. There is work here. I'm going to pull this example on the side, and I'm going to go through the steps. I'm going to pull this on the side. We'll come back to this. And I want to go through the steps on it. And I want to do one step at a time. We are assuming that you've mastered, or not mastered, but you're comfortable with the material that's been presented in Math 119. I'm sorry, I made a mistake. In Math 086 and in 092. And some of that was just simply order of operations. All right, let's go through that. So we have 6x. Whoops, let's go back to black ink. 6x plus, I'm going to use the distributive property of multiplication. I want to see what that says. We're going to take this number here, which is plus 3, and distribute these two terms, one at a time. What's 3 times 2x? 6x. Now, someone says, what are you doing? I am simplifying. I am removing a grouping symbol. And what's 3 times minus 1 minus 3? Let's do the other side. This number 5 is distributed across these two terms. What do you get there? 5x minus 10 plus 1 plus 5x. All right. I'm still on step number 1, which is simplification. What am I going to do? I'm simplifying the left side and the right side, and I'm doing one thing at a time. What's 6x plus 6x? 12x. That's the left side. What do you get on the right side? 5x and 5x is 10x. Minus 10 plus 1 is, I'm sorry, I forgot to put the x there, is minus 9. Now, let me repeat what I did. 6x, 6x, 12x. There's already minus 3 there. 5x and 5x is 10x. Minus 10 plus 1 is minus 9. Now, what are you going to do? Well, it says get the variable term. Let me point out what that is. On one side, by either adding or subtracting a variable term from each side. What I'm going to do is I'm going to subtract 10x from both sides. And what do you end up with? 2x minus 3 is equal to minus 9. Now, someone's going to question, do you ever make a mistake all the time? This is why we provide a key for you. But more importantly, we can actually check ourselves without using a key. And we'll get to that later. All right. So what do I do first? First step was simplify both sides. That's done. Second step, get the variable term on one side. I've done that. The variable term's on the left side. I'm going to the next step. What does it say? Get the constant on the other side. By adding or subtracting the same constant, I'm going to add 3 to both sides. And what do you get? You get 2x is equal to minus 6. All right, so the variable terms on the left, the constant terms on the right. Now what am I going to do? Go to the next step. What does the next step say? Divide both sides by the variable's numerical coefficient. And what's the variable's numerical coefficient? 2. What do you get? X equals -3. Now, although for a lot of students that's the final step, I'm going to claim I don't know if that's true. So what I want to do, which is really difficult, I want to go back and I want to see if it's a true statement. So someone says, what do you mean true? I'm going to go back up here. I'm going to circle it for you. And this is the original statement. And I want to see if -3 makes it true. Now, what's 6 times -3? It's the first thing I see. 6 times -3 is -18. Plus 3. And let's see, what's 2 times -3? It's -6, right? I know it's tough. Mistakes happen, though. Well, let's see. It's 5. And then I have -3 -2. Plus 1. I'm just plugging in, by the way. And what's 5 times -3? -15. Okay? I know this is tough. Let's keep working through it. -18 plus 3 times -7. 5. -3 -2 is -5. Plus 1. -15. Just keep going. -18 -21 -25 plus 1 -15. Boy, it's a lot of work, isn't it? What's -18 -21? Well, it's going to be -39, right? Let's see. -25 -15 is -40. And -40 plus 1 is -39. So I'm pretty comfortable this is the correct answer. All right, I'm going to go back to my notes. I know that's a difficult problem. And what I want to claim over here is the work is all typed up for you, right? So you could study that work, whether it's typed up or me printing it at the whiteboard to make sure you understand what the steps are, right? I also want to claim to you, there's also a video over here for those students that need supplemental support, and many students do. And if you need supplemental support, take that support. You should watch these videos if they're helpful. There's no need to if they're not helpful. They're not adding anything to the lecture. I also checked it and I found out what we expected to see. By the way, don't worry about the QED, but it's a Latin abbreviation for saying that we show what we're supposed to show. So I'm going to claim over here, it's really kind of important that you understand what we just did. All right. So incredibly important here that equality demands from you. Write this down for you. That equality demands equal treatment. I can't say this enough times. Equality demands equal treatment. And by the way, it's an algebra class, so our equal treatment is going to be this. Whatever you do to one side, do to the other. What are we doing? Basically, arithmetic operations. We're adding things to both sides. We might be subtracting things from both sides. We might be multiplying both sides by the same thing. We might be dividing both sides by the same thing. The bottom line is please make some attempt to be fair. All right, let's go to the next page. And I want to do this example over here. I'm going to pull it on the side. I know this is difficult, and we're starting with difficult examples on purpose. I'm going to take this example here. I'm going to pull it on the side. All the work is there. And push this over here. I'm going to do this problem now. Now, what I'd recommend for a large number of students are looking and saying, this is crazy. I don't think I could ever do that. And the reason is that there's a fraction. So what I want to do is I want to look at it. And if you struggle with this, that's fine. Struggling is not a bad thing. What I'm going to claim over here, though, when I'm looking at the problem, I want to claim this whole thing is one term. This is one term. And this is one term. This is an equation. What I want to do is treat both sides the same. Fractions are killers for a large number of students. So what do I see? I see a denominator, 12, 6, and 12. What I would recommend for you to do, if the fraction's bothering you, is write down the LCD. What's the LCD? If you look at it, I hope it's simple. For example, between 12 and 6, the least common denominator would have to be 12. What I'm going to do here is I'm going to multiply both sides by 12. Now, someone's going to say it's going to be really tough to do. I don't think so. Let me write it down for you, though. So it's 12 times the first term. We'll do that in a second. Minus 12 times the second term equals 12 times this term. What do I notice immediately? Simplicity. 12 goes into 12 once, goes into 12 once. When we put a slash through things, we mean it goes in one time. 6 goes into 6 once, but it goes into 12 two times. 12 goes into 12 once, goes into 12 once. Let's do the first one. I want to tell you what it is. It's 1 times these two terms over here. What does that give me? 2x minus 5. I'm going to hold off on the second term, and I want to do this term over here. What do I get? 1 times 11, which is 11. I'm going to talk about this one over here. And this is the problem for a lot of students. They see this, and they forget about it. What is it really? Minus 2 times those two terms. What's minus 2 times 3? It's minus 6. What's minus 2 times minus x? It's plus 2x. Whoops. Someone says, you spent a lot of time doing that, and that's not helpful to me. I'm going to claim it is helpful. I'll tell you why it's helpful. The fraction's gone. And most students can handle whole numbers. So what's 2x and 2x? 4x. What's minus 5 minus 6? Minus 11. Okay, what did I accomplish? Each side is as simple as it gets. What am I going to do now? Get the variable term on one side. Well, it is on one side. It's on the left side. Next step, I'm going to get the constant on the other by addition, subtraction of a constant. I'm going to add 11 to both sides. And what would you get? 4x equals 22. Now what am I going to do? I'm going to divide both sides by 4. That's the numerical coefficient of the variable. And what do you get there? This is intentionally difficult, I know that. X equals 11 halves. I'm done. Okay, here comes the trouble. For a lot of students, checking this thing it's not worthwhile. So could I have made a mistake? Of course. So in my notes, what I do is I provide answers for you. And I believe I didn't make a mistake that the answer here is going to be 11 halves. However, if I look at my key and it says it's something else, I will have to assume I made a mistake somewhere and redo the problem. And this is part of your learning exercise, looking at an answer key. Let me go through that with you. Back over here. And I'm looking at it, and what do they say? They say X. I'm going to circle this for you. Is 11 halves. What did we say? 11 halves. Here's what it says over here. Checking. I'll write this down for you. Checking may be difficult. Push this over. May be difficult, but I do suggest you try. By the way, when someone says something's difficult, you don't know what's difficult until you try. It says I'll do it in class if requested. You just need to ask. I'm going to pretend someone asked. I'm going to go back to the original problem, and I know it's going to be a nightmare. I'm going to check it. And let me do that. And I'll point out what I mean by that. I'm going to take this thing here and plug it back into the original. All right. Let me write the original down for you again. So it's going to be 2 times 11 halves. Right? What's 2 times 11 halves? 11. Minus 5 over 12. Minus, I know it's tough, 3 minus, well, what's x 11 halves? Whoops. over 6. It's tough. There's no doubt about it. This says 11/12. I'm checking, by the way. This is called a check. What's the problem with checking? It may be wrong. What's 11 minus 5? It's 6/12, right? This is a problem for a lot of students. It's arithmetic. And I'm looking at it. And what I'm going to do over here, it might seem strange to you. I don't like the way it's written. I'm going to multiply the top and the bottom by 2. Now you said I wouldn't do that. We're not saying you have to do that. I'm just saying I'm thinking to do that. So what would this give you? I'll write this down. 6 minus 11 over 12. Let's take a look at this. 6 over 12 minus, what's 6 minus 11? It's minus 5/12. This is 6/12 plus, I think I made a mistake somewhere. Oh, no, I didn't make a mistake. I'm sorry. 5/12. What's 6 plus 5? 11. Checking can be difficult, and I understand that. So what we do throughout the notes, we realize students have trouble. So what do? We actually provide answers for you to aim for. Next up, and this was a lecture. For some students, it was a very long lecture. Next up, we're going to do examples. All right, be prepared to do examples. What I mean by that is you should have paper and pencil out, and you should make some attempt to copy what I'm doing at the whiteboard. But right now, the lecture's over. General format of the course is going to be this: short lecture, me doing examples, then you doing examples on your own, and then you doing WebAssign. And that's how simple it's going to be each time we do a section. Okay? Thank you for your attention, and I'll see you next time.